In 10A, we were talking explicitly about sequences in general. Okay, so it could be any form of a sequence. Here we're talking about arithmetic sequences. So that's a particular type of sequence. And so, an arithmetic sequence is one in which each term differs from the previous one by the same fixed number. So it's going up by the same amount each time. Okay, so it's a very specific type. We've got a general formula there, which we'll talk about in a moment, and we're straight into the example. So consider the sequence. It goes 2, 10, 18, and 26. So the first part says, show that the sequence is arithmetic. Okay, so the way we're going to do that, let's just list the first four terms, because they're given there to us. We've got 2, 10, 18, and 26. And what we're going to show is that the difference is the same after each successive term. So if I do term 2 take term 1, that's going to be 10 take 2, which is 8. All right. Term 3 take term 2 is 18 take 10. Okay, so it doesn't matter where we are on the sequence. The difference between successive terms is always 8. Okay, so let's articulate that. We've got the common Okay, so if the common difference is the same, it will be an arithmetic sequence. Okay, so the difference between the second term and the first term, the difference between the third term and the second term, the difference between the fourth term and the third term. Okay, we can see it's going up by 8 each time. Okay, part B, find a formula for the general form. Okay, so right at the top we've got a description of the general formula. It is the nth term. So what I'm saying is nth, the nth term. So for any value of n, the nth term is going to be t1 plus n take 1 times d. N is our variable, okay? Could be the 25th term, could be the 100th term. N is our variable here. We've got our value of t1, that is 2. Okay, so let's start filling this in. t1 is 2. And we saw before our common difference is 8. Our value of d is 8. That's how much it's changing by each time. And we're just going to expand this bracket and then collect any like terms there. Okay, so the nth term will be 8n take away 6 for any value of n. If at any stage I am going too fast, let me know. Part C, using your formula, find the 28th term of the sequence. So that was part B, so here's part C. That means we're finding T28, the 28th term. So if we were to keep repeating this pattern, 2, 10, 18, 26, all the way down, like we could do it manually, but it'd take a very, very long time. So let's use our formula. T28 is equal to 8 times n. All right, and we know n is 28, and then take away 6. 8 times 28, take away 6, 280. All right, so the 28th term of this sequence will be 218. I'll jump up on this whiteboard. Spin that for me. So part D, and there's two parts to this. Is 1004 a member of this sequence? Okay, so that means if you keep going with this sequence, so 2, 10, 18, 18, 26. If you keep going, will 1004 appear on this sequence? Okay? And so what we're going to use, we're going to say, well, again, you could go all the way out to 1004, it'd take a very long time, but we can actually use our formula here. And so what we're going to say is 8n take 6 equal to 1004? Is n going to be a whole integer value? So I'll unpack that. So to solve this equation, we're going to first get rid of that minus 6. We add 6 to both sides. So we're going to have 8n is 1010. And then divide both sides by 8 to get n by itself. Okay, now put that in my calculator. I got 126.25. Okay, so what this means is it's in 1004 is in between the 126th term and the 127th term. It's in between these two terms, so it is not a member of this sequence. Okay, the simple way is this is not a whole number. It's not an integer. Okay, so we're going to say because n is not an integer, therefore 1004 is not an integer. Okay, so just mathematically, I've shown you guys this before. N-E-Z. Okay, remember that. The number n, this symbol here means belongs to, and this z here means the set of all integers. Integers are just whole numbers. So I've got the number n belongs to, it just means n is a whole number. Okay, so that's the mathematical way of writing it. But our statement is it's not an integer, so we just put a line. N does not belong to the set of all integers, therefore 1004 is an integer. So either is fine. Okay, you can write it like this if you want to. If you want to start using the mathematical language, which we will develop, this is the way to write it. Okay, how about 810? 810? Yep. Is 810 a member of the sequence? This is part 2. So same deal, we could just map out the sequence the whole way, or we can use our formula. So we've got 8n take 6 is 810. Add 6 to both sides, we'll get 816. And divide both sides by 8. 102. Okay, this is a whole number. Alright, so so we know that's therefore, because is the inversion of that. So because n is an integer, therefore 810 is a member of this sequence. Okay. Any questions? All right, so we'll move on. Has anyone not finished writing any of this first part down, or I can rub it off? Excellent. So we're just going to start with question 1 and 2 today. All right, we'll see how we track along. Okay, a sequence is defined by, we've got the nth term is equal to 5n plus 11. Prove that it's arithmetic. Okay, so let's just list a few of the first terms, and then we'll demonstrate that the common difference is the same. Okay, so the first term is going to be 5 times 1 plus 11. Okay, t of 1, we're putting the number 1 where the n is. That'll be 16. T of 2 is going to be 5 times 2 plus 11. We have 21. 26. 31. Okay, and we can see the common difference. 21 takes 16, 5. 26, take 21, 5. 31, take 26, 5. Okay, so we do need to describe that. We need to provide justification because the common difference is 5, therefore the sequence is arithmetic. Excellent. Find T1 and D. All right, so we've already stated them here, but let's just state them for part B. T1 is 16 and D is 5. Now, what is the largest term of the sequence that is less than 500? Okay, so part B probably should say, rather than just finding T1 and D, find the general term, but we'll do that in part C. So what is the largest term of the sequence that's less than 500? So what we need to do for, it's given us the sequence, so we're not going to need to find that out. So we're going 5n plus 11, if it's going to equal 500, perhaps 500 is a member, but it's saying what's the member of the sequence, the largest member of the sequence that is less than 500. So let's solve this, and I'll show you what I mean. So 5n plus 11. We want to solve this. We're going to subtract 11 from both sides. We will have 5n is 489, and we'll divide both sides by 5 to get n by itself, and I got 97.8. Okay. What this means is the 97th term is below 500. Okay, and the 98th term is going to be above 500. Now, it doesn't say what is the largest term, what is the number of the largest term. It says what's the value of the largest term. That's what it's insinuating. So that means we have to find what is T of 97. Not 98, because that's going to exceed 500. So the one that's just below, or the term below the 97.8 term is the 97th term. And so we'll use our formula here for that. 5 times 97 plus 11, 496. Okay, so what that means is the 97th term of this sequence, if you kept going with this sequence, kept going all the way, you're going to get 496, okay, which is the 97th term, after 97 times writing it out. The next term would be 501, okay, which is above 500. It says here quite clearly, for what values, what is the largest term for the sequence that is less than 500? Okay, our last one here. For what values of n are the terms in the sequence less than minus 150? So, just in terms of number line, okay, here's 0, here's minus 150. If it's less than minus 150, it means it's this side of 150. Okay, so it's more negative. That's what we mean when we say less than. So, same deal. Let's start with the 5n plus 11, and we're going equals minus 150. We're going to solve this one. So we'll take 11 from both sides and divide both sides by 5. I've got minus 32.2. Okay, so what that means, remember here, these are values, right? And if we're tracking along, we've got term 1 was 16. Okay, and so that means we're going back the opposite way. We could have term 0, and term minus 1, and term minus 2. We can track these terms. Because it's a sequence, we can go forwards and we can go backwards with it. And so we're going to have a negative value in here. That's absolutely fine. And what we find is 150 occurs at negative 32.2. Okay, so what that means is this is the 32nd term, and this is the 33rd term, because it's less than. All right, and so for what values of n, let's say, for what values of n are the terms in the sequence less than minus 150? And what we're going to say is we're going to say if n is less than minus 33, less than or equal to minus 33. So that means minus 33, minus 34, minus 35, and on to negative infinity. Alright, so that we'll stop there because this is actually quite a big exercise. So I'll get you guys to have a bit of a go at it. Does anyone have any questions about what we've gone through? E-Rad? Say again? Yeah, excellent. I'll float up there. Alright, so let's get into it. So that's exercise 10B. On the front here, you'll see a checklist. Okay, so they're the questions from each exercise that we want you to get done. Check them off when you're done them. Let's get into it. Okay, if you need some stuff, if you haven't brung it, you can go get it. Okay, so textbook, get one of each, yellow and a blue one. Yeah, fantastic. Thank you.